So let's solve this integral through trigonometric substitution. Supposedly, we have three cases, but then we need to make this one, basically we need to do completing the square so that we could have a form such as the following. So this is case 3, case 2, case 1. More on that later. Let's complete the square first. So k is going to be equal to the coefficient of the second term, and then times 1/2, and then raised to 2. K is equal to 1. U, well, we can't really know that yet. Let's copy the expression, and then plus 2. This is where we put the 1. So we write a plus 1 and a minus 1. Don't forget the raised to 2. And then we combine these 3. So we have x plus 1 raised to 2. And then the positive 2 and negative 1 will have a plus 1. And then technically 1 raised to 1 is still 1. So it doesn't change anything if we put a squared. And in this scenario, we see more clearly that what we are given is, it basically resembles the form u squared plus a squared, or either way, it's the same thing. This corresponds to case 2. And now we identify what our u and a are. So u is x plus 1, a is 1, right? And then we let u equal to, since this is case 2, this is tangent. So don't forget the alpha tangent theta. And then you substitute u as x plus 1, and then substitute a as 1. Technically, it doesn't change anything. You can just write tangent theta. And then don't forget to transpose. Only x will be seen in the left side of the equation. And then dx, you find the derivative of this. That's easy. Derivative of tangent theta is secant squared theta d theta. This one is a constant, so just 0. So you don't write it anymore. Now that you have these all these details, you draw a triangle. This is our theta. Since this is case 2, our triangle is supposed to look like this. So u is over there, a is right here, and hypotenuse, basically a squared plus u squared is at the hypotenuse. Okay, so u again is equal to x plus 1, a is equal to 1. The hypotenuse, a plus x plus 1 squared. Okay, now let's substitute. So what do I mean by substitute? Coming from here, what is our dx? Our dx is this, right? So in place of dx, we write it equivalent. So secant squared theta d theta over, our x is tangent theta minus 1, right? So we just substitute. Okay. So we simplify from there, from here onwards. I can see already what can be cancelled. So these can cancel already. What else? These as well. So what we're left with is tangent squared theta plus 1. And then don't forget the squared. Tangent squared theta plus 1 is also secant squared theta. Remember the tool. And since this is squared, we can make this raised to 4. The exponent. So we can cancel what's above. This becomes 2. So we have 1 over secant squared theta. We can rewrite that as cosine squared theta. So far so good. Okay. We're also going to use another tool. 1 minus sine squared theta. Okay. Actually, there's another way of there's another tool that we can use, although I'm not sure if it's gonna lead to the same answer. Cosine squared theta is also the same as 1/2 1 plus cosine 2 theta. We'll see. We'll try to solve using both methods. So 1 over 2, put the constant outside. We have actually, let's just distribute. No. Cosine 2 theta can be rewritten in another way, although I don't think that's gonna be, it's gonna make the solution longer. Let's try u. Du is 2 d theta. Yeah, we can basically the integral of cosine 2 theta, or basically cosine theta, is equal to sine theta. The theta here is 2 theta. But since we have du as basically the du has a coefficient, don't forget that we have to multiply the entire thing by 1/2. Let me confirm something first. Okay. Yeah, we're on the right tracks. Let's continue. So we see theta here. We can now substitute. Basically, since our situation right now is classified as case 2, we write tangent. So theta here will become arctangent. And in the abbreviation SOHCAHTOA, tangent is opposite over adjacent, right? So O over A plus 1/2 sine since this is sine 2 theta, it's not sine theta where we could just easily put O over H. So whenever you see sine 2 theta, always rewrite it as 2 sine theta cosine theta. This is another identity that you have to know. Integral calculus has a lot of these, so you have to be very familiar with it. 1/2 arctangent. Let's already substitute. What is our opposite? Coming from the point of view of the theta angle right there, opposite is x plus 1. Adjacent is 1. These two values can cancel. So we're left with sine theta, that is opposite over hypotenuse. Cosine theta, that is adjacent over hypotenuse. Plus c. Don't forget the plus c. 1/2 tangent, arctangent x plus 1 plus our opposite again is x plus 1. Hypotenuse is 1 plus x plus 1 squared times adjacent, which is 1, and rewrite the hypotenuse. This is already good. We can further simplify. So basically the radical sign will be removed if you multiply the same thing. They're essentially the same thing. So that is the final answer. So we found the final answer using cosine squared theta being equal to this. Let's try using 1 minus sine squared theta. Ideally, I think they're supposed to be the same answer, but for some reason, from my experience, it seems to be that although there are many ways to solve it, only one way is usually correct, or at least the same as the answer key. So we'll see. Sine squared theta. Okay, so the dilemma that I am seeing right now is that this is sine squared theta. It's very easy to integrate if you're given just sine theta, but you have a squared. If you think that you can do this, basically 2 plus 1 over 2 plus 1, that's not right. That's not the correct way. So if you use a tool, this one is technically equal to this. It's essentially pointless. Let me show you. Integral of d theta is just theta plus integral of cosine theta. And this cosine theta, you use a tool again, 1 minus sine squared theta. You go, basically you end up in a position where you were before. and these cancel. You get what I mean? So in order to break that cycle, actually there's another way. So let's say you're in this situation. Earlier, cosine squared theta is equal to this, right? There's another identity that you'd want to memorize. So sine squared theta is also 1/2 1 minus cosine 2 theta d theta. Let me just confirm if if what I remembered is consistently correct. Yes, it is correct. Okay, so yeah, this is the faster method, but either way, it should lead to the same answer. So theta minus 1/2. Here we go again. This is case 2, right? So arctangent O over A minus 1/2 theta plus 1/2. Okay. Wait a minute. So we have 2 theta, right? du is equal to 2 d theta. So we put another times 1/2 from outside. If we want to integrate this already, cosine becomes sine. Don't forget the 2 theta. And don't forget the plus c. So this 1/2, to clarify, it came from du. Okay, this other 1/2 came from distributive property, right? So arctangent opposite over adjacent, just write x plus 1 minus 1/2 Okay, I think, yeah, we're in the right tracks. Frankly, kind of nervous, but it is what it is. It's very risky. Okay, let's just move it here so we have more space. We have sine 2 theta, right? So what did I say earlier? We can rewrite it as 2 sine theta cosine theta. So also, you can simplify this portion. So 1 is equal to 2 over 2, right? So basically just 1/2 arctangent x plus 1 minus 1 and then minus 1 over 8. These can cancel, simplify. We have 1 over 4 instead. Sine theta, sine is O over H, right? Cosine is A over H plus C. Getting familiar? Let's see. Wait a minute. Earlier, if you distribute 1/2, this is supposedly 1 over 4. And when you cancel, you have 1/2. or if you don't distribute, you can just write the answer like that. Yeah, that would work. In our scenario, I'm seeing an issue with the fraction. Supposedly the answer is the same. We will end up in the same answer. That this is this. However, the fraction. This is 1/2, this is 1/4. I see the problem. So here I assume that it has not been distributed yet. So there you go. Okay. So yeah, essentially we are going to end up coming from here, we'll have this, and if you factor out 1/2, we get this. So that's the final answer. Either way, the only difference is that you took an extra step here. You could have rewritten cosine squared theta as this one already, but because you used a tool, technically this is equal to cosine squared theta, and sine squared theta is equal to this. Okay, just essentially, you just essentially just have to remember these are equal. These are also equal. If you notice, the only difference is the sign. So we have a 1/2 and then a open close parenthesis 1 and then cosine 2 theta. In cosine, it's plus. In sine, it's minus. Okay? So that's it. Next question. Let's try okay. Again, we're gonna complete the square. Our second term is 4x. The coefficient is 4. So k is equal to 4. And then times it with 1/2 and then raised to 2. K is equal to 4. We write our problem according to decreasing degree. So highest degree first. And then next is 4x. And then next is 4. And then minus 4. Always a plus and a minus of it. Okay? So okay, we have what does this resemble? So u squared minus a squared. This is case 3, secant. So identify what our u is. That is x plus 2. Our a is 2. Let u equal to a, since this is case 3, right? Secant theta. So substitute x plus 2 is equal to 2 secant theta. Transpose x is equal to 2 secant theta minus 2. Or in other words, 2 times quantity secant theta minus 1. Dx is equal to Actually, wait, let's just stick with this. To the derivative of secant theta is secant theta tan theta. Don't forget the d theta. Okay, now let's draw the triangle. Since this is case 3, u will be here, a will be here, and the u squared minus a squared is at the opposite. Okay, so now let's substitute. Dx is 2 secant theta tan theta d theta over square root of 4 times our x is 2 secant theta minus 2. Oh, wait. This is an important reminder. So, what did we do in the previous problem? So it's ah, that's also possible. Either way. Either way works. What I did in the previous problem was substitute based on this. But since we did completing the square, we could have used this so that the solution would be shorter, ideally. Let's do that here. So instead of using this as our basis, we use this. X is 2 secant theta minus 2 plus 2 squared minus 2 raised to 2. Okay, we're basing on this. We can cancel these. So we have 4 secant squared theta minus 4 secant squared theta minus 1 could be rewritten as tan squared theta. Cancel. Don't forget the integral sign. The constant, place it outside. Okay. Now what? We can rewrite this as secant theta. Tangent, the inverse of it is cotangent, right? Secant is 1 over cosine. Cotangent is cosine over sine. Now we can cancel something else. One more time. So inverse of sine is gonna be cosecant. So cosecant, yeah, it is. Wait, something's wrong. Did we consider in the denominator? So after, so these cancel, right? 2 squared, that's 4. Secant squared, I forgot to write the radical sign. Okay, let's just fix that. Everything else has to be repeated. So it's crazy if you think about it, how one minor mistake can change the entire answer. So as for my professor, there's not much generosity when it comes to consideration. You got the idea right, but because of basic carelessness, it's not that you receive, basically you don't get much merits. So extra careful. Inside, we have tangent squared theta, right? It has a squared, but because there's a square root, the exponent cancels, so we only have tan theta as a result. And they cancel, so we have integral of secant theta. If you know your basic integration formulas, the integral of secant theta is equal to the natural log of secant theta plus tan theta. Don't forget the plus c. So ln secant is the inverse of cosine. Cosine is a over h, right? So other way around, h over a. Tangent is o over a. So katoa. Hypotenuse, let me just label. U is equal to x plus 2. A is equal to 2. The opposite is equal to that. Okay? So hypotenuse is x plus 2. Adjacent is 2. Opposite is x plus 2 squared plus 4. Adjacent is x plus 2. So that is it. Oh, wait, sorry. This is adjacent, right? I wrote what's the hypotenuse. Again, be careful. As I hope to be careful as well. The numerator, by the way, could be simplified as because basically the answer is right. The only difference is that in the answer key, the numerator is 4x minus x squared. Where did we get that? Actually, at this point, I'm not sure. But essentially, everything else is correct. Okay? So, that is number 5. Let's try another. Actually, yeah, I'll end this video. I'll see if I can record a few more practice questions. See you.